Hey everyone, I'm Ryan Goodwin. This is my presentation on the COVID-19 crisis currently happening. I analyzed the United States as a whole and the state of Ohio specifically. So my data comes from the COVID Tracking Project, which is a source used by organizations such as the White House and the Wall Street Journal. So it's a reputable source. And the Ohio data specifically that's used in the COVID Tracking Project comes from the Ohio government website. The first data point we're using for the United States is March 13th. So that's when President Trump declared a national emergency, and that's when I think a lot of the data reporting started to be taking more serious. And the COVID tracking project assigns data quality grades to every state. And Ohio's first time, they moved from a D to a B on March 25th and stayed at a B consistently through the present. So that's why we're starting the Ohio data analysis on March 25th. So both positive percentage and total cases and deaths have their flaws. The positive percentage is heavily influenced by the false positive and false negatives, which some reports estimate are up to 5% for false positive test results and 20% for false negative rates. Total cases and death, they're prone to the same errors, but they're also prone to scaling issues. So because the positive percentage better captures the increase in testing that has happened over the last couple months, I decided to move forward with positive percentage as my metric for measurement. So looking specifically at the full country data first, I plotted the realization, and you can see that the mean and the variance are changing over time. So that led me to believe this data is non-stationary. You can see the peak in spectral density is 0, so the highest frequency is 0. Now that doesn't really prove anything in terms of stationarity, but as the time goes on, you can see the mean is definitely increasing by looking at the realization. The lowest AIC you can see here is an ARMA 5.2 model and an AR5 model to fit to the data. So here's the factor table outputs in the bottom of the screen there you can see. And these are what we're going to move forward and model with. So both models trend towards the mean. I think the AR5 forecast actually captures the volatility of the realization better. You can see it models the oscillation better at the end there. And the ASC is actually pointing to the ARMA 5.2 model, which I tend to lean towards because of the non-stationarity of the realization. Something strange popped up in the Ohio data. There were 6 instances you can see here in the first chart, the realization where the number of new positive tests equaled the total number of new tests. So this was the official government data, and I didn't like that very much. I felt like something was off about that. So I replaced these points with the mean of the previous 3 points for each set of data. And after that imputation, you can see there's some wandering behavior to the realization, and there was enough evidence for me to move forward with it as a stationary realization. For the Ohio data, you can see that the lowest AICs were an ARMA 1.1 model and an ARMA 4.1 model. There's, once again, the factor tables below. And these are the model forms we're going to use to forecast the next 20 points. For the forecast of the Ohio data, both models once again are trending towards the mean. Neither model is capturing the volatility too well, but the ARMA 4.1 I think does a slightly better job. And the ASC is also pointing towards the ARMA 4.1 model, so I think that is the better representation for the forecast overall. Some next steps for this project are going to be to add some exogenous variables into the analysis because it's pretty hard to forecast with a univariate analysis with this data, and it's pretty involved data. So I'm going to research some extra features that can be added to the model and check out some other modeling techniques that I could use. Anyways, I hope you enjoyed my presentation, and I'd love to hear the feedback to improve on it. Thank you.